Okay, so in the previous session, we were talking about Kubernetes volumes, right? So what we have discussed in that Kubernetes volumes, we discussed the MTDAR host path, right? Basically, we don't use that in the real time because we want a persistent storage. Okay, means the purpose of creating volume is even the pod gets deleted, then still we need our data should be available. So if you use MTDR, then it is not possible to store the data. But if you use host path, then it's possible to store the data. But when you mention three replicas or two replicas, then it is going to take the worker nodes storage. So the data is not going to be synced. So that's the reason even host path is only works if you mentioned um, single replica. Okay, and that too it is taking the worker node storage. So if something happens to that worker node, then it is not going to get the data. Okay. So in today's session, we will talk about PV and PVC. Okay, PV physical volume and in PVC physical volume claim. Now in the Kubernetes document also we can able to see that kubernetes.io. We can go to the documentation here and under the concepts you can see under the concept storage, and here we can see persistent volumes. Okay, so here persistent volume is a piece of storage in the cluster that has been provisioned by an administrator or dynamically provisioned using storage class. It is a resource in the cluster just like a node is a cluster resource. So PVs are volume plugins like volumes but have a lifecycle independent of any individual pod that uses the PV. So this API object captures, and a persistent volume claim is request for storage by a user. It is similar to a pod. Pods consume node resources and PVs consume PV resources. So pods can request specific levels of resources. Claims can request specific size and access. Okay, so here to understand it, we have a cluster. Okay, assume whether it can be EBS, sorry, um, bare metal like cubadium or cops. Okay, it can be anything, or it can be manager service, either AKS or AKS GKE. It can be AKS or GKE, or maybe it's maybe bare metal, like we manually create virtual machines, like how we installed the cluster software Cubadium manually, or maybe if you use COPS. So as I said, COPS is not compatible, not fully compatible with the GKE or AKS. So maybe assume you installed it with the Cubadium concept. Manually you install. It can be anything. So you create virtual machines in either AWS, or Azure or GCP. These are cloud providers. So you are manually creating virtual machines and you are installing Kubernetes software with Kubedium concept and you are creating a cluster. This is one way, bare metal. Another way, this managed service. These three cloud providers are providing managed service. We already discussed. So they are going to manage the software, and they will help us in case if we get any kind of issue in the Kubernetes. It's their responsibility to help. Okay. So in this scenario, we are not going to see master. We can just only send the API calls. But remaining the worker nodes concept is same. Okay, there or in bare metal or here it's same. So bare metal also it can be like we can give cloud names GCP and Azure. Okay, these are cloud providers and these are services providing the cloud vendors. Okay, so that it's a managed service. They are going to manage it. We are not going to uh, install with Kubedium. So it can be anything. Okay, this assume these worker nodes can be anything, this one or this one. For physical volume it doesn't matter. Okay, so now we discussed about mtdir and host path. So these are not useful as a volume, so that's why we have a concept called physical volume and physical volume claim. Now what it is telling, the physical volume, it is a resource in the cluster just like a node is a cluster resource. So here this worker node is a resource. This worker node is a resource. What it is providing for a pod, it is providing CPU and RAM. That's why we are having worker nodes. To deploy an application as a pod, it need resources. What resources it need? It need CPU, RAM. Okay, so that's why we have this worker node. We call it as a resource. Same way, physical volume is also one of the resource. Okay, this is also one of the resource. At the time of namespace topic, I told you name some resources will be not part of any namespace. That is, these nodes are not part of any namespace, and the storage is not part of any namespace. Okay, this is also one resource like a worker node. Okay, so this is PV storage. Okay, this is also one of the resource. So when we are deploying pod, in the pod specification, if you are mentioning that it needs some volume, then that volume will be provided by the storage. If you mention some CPU and RAM utilization, then these worker nodes will give that specifications. Okay, resource CPU RAM will be provided by this worker nodes. So that is a difference. So then what is persistent volume claim is a request for a storage by a user. It is similar to a pod. Okay, pods consume node resources and PVs consume PV resources. So how the pods are using the CPU and RAM of a worker node, same way the PVCs will consume PV resources. Means, see, it's very simple. How many of you are aware about the Linux operating system like Linux Logical Volume Manager? Are you guys are aware about Logical Volume Manager in the Linux?
No, not sure.
Okay. Hmm. Those who know Logical Volume Manager in the Linux, it will be easy to understand that. Or else, let it be very simple. So will create a physical volume of 100 GB. Okay. So 100 GB physical volume when we are creating. So this 100 GB physical volume can be used for a PVC claiming. Okay, we are claiming uh, this volume as a PVC. So this PVC will be used to any of the pod. Okay, so when you are creating a pod, you will specify in that pod that uh, use this PVC, so that that pod will be mounted with this 100 GB. Okay, so when we are creating this PV, so this PV we are claiming, physical volume is claiming. Okay, so physical volume we are claiming from this 100 GB, and this PVC we will give the definition inside the pod YAML file, and then this pod, whenever it got deployed, then it will use this PVC. Okay. So while persistent volume claims allows a user to consume abstract storage resources, it is common that users need persistent volumes with varying properties such as performance for different problems. So cluster administrators need to be able to offer a variety of persistent volumes that differ in more ways than just size and access modes without exposing users to the details. Okay. So here the definition, the concept administrator and user, why it is they are calling is, see, let's say I am the Kubernetes administrator. My responsibility to make sure the PVs are available. User in the sense, see, nowadays in real time, sometimes even developers are deploying their applications. Let's say if we talk about full stack developer, so the full stack developer means what? He need to know the knowledge, he need to have the good experience on the front end like HTML, CSS, JavaScript, and he should know about the backend application. Okay, like Java, Python. Okay, and he should know the database also. And apart from that, the developer also should know the deployment. So nowadays, even developers also can able to do our job. Okay, they can also become DevOps engineer because they'll get very good package if they mention that they are a full stack developers. So they can deploy. What is the deal in deploying the application? They can create repositories in the GitHub. They can create Jenkins pipelines. If you can do coding, then do you think it's easy? That it's tough to do the configuration of Jenkins pipeline and creating GitHub repositories and creating deployment and the Kubernetes? It's not a big deal for them. So sometimes they can also deploy, but as a Kubernetes administrator or maybe as a DevOps engineer, they are not going to configure Kubernetes from scratch. They can do that, but still, uh, as a DevOps engineer or as a Kubernetes engineer, administrator, it's my responsibility to take care the manage of Azure cloud and managing of maybe the cloud vendors and the managing of this cluster. Then we call it as an administrator. If he is deploying the application, then he is called as a user. If applications also deploying by me, then I will be the user and I will be the administrator. But sometimes he is using, so he is not going to create this PV. It's our responsibility to create this PV. Then when he is deploying the application, maybe it's in the deployment.yaml, like we discussed, right? Different ways to deploy the application. So when we deploy the application deployment type, then there in the container specification, he will mention his application needs a volume. So he will give the specifications, physical volume claim he will mention, and he will check with us whether uh, any PVs are available. So that's why his intention is user means whoever deploying the application. Administrator means cluster administrator means maybe Kubernetes administrator. Obviously, it's a DevOps engineers. Okay. So life cycle of a volume and a claim. Life cycle means when you create it. So there are two ways PVs may be provisioned, static and dynamic. Means this PV when I'm creating, this can be created in two ways. So one is static, means manually I am creating the physical volume. So cluster administrator creates number of PVs. They carry the details of the real storage which is available for user used by cluster resource users. So manually I am creating the physical volumes by using the YAML file. Okay, we can create. Dynamic means when none of the static PVs the administrator created match a user's persistent volume claim, the cluster may try to dynamically provision a volume specifically for the PVC. This provisioning is based on storage class. So the PVC must request a storage class and the administrator must have created and configured the class for dynamic provisioning to occur. So here, let's say I want to create PV when I'm claiming for PVC. So that is called dynamic. So automatically PV gets created, but this is depend upon the storage class. So here very important to know about the storage class. The storage class is what kind of storage class we are using here. Okay, when we are talking about PV, where it is getting created, PV. So here always you need to remember this PV can be created in different ways. Okay, um, okay, if you see, this is persistent volume claim, and this is persistent volumes. So here, this persistent volume, when you are creating here, this PV, whatever you are creating, these are the different types of persistent volumes you can create. So Azure file, Azure disk, CSI, fiber channel, flex volume, NFS, iSCSI, cluster FS, host path. Okay, so these many types are there. So when you are creating this storage, PV storage, you need to define the storage class. Means from where would you like to create it? Assume this this is a Kubedium concept created in the AWS environment. Okay, it's not an EKS, it's an AWS environment, or either it can be EKS because EKS is also belong to the AWS as a managed service. Then you can use this PV as an EBS, right? EBS volume you can create. Here if you see AWS Elastic Block Store. So then your storage class will be AWS. Okay. You will have this name Elastic Block Store. The storage class names will be there. Hmm. Okay. Hmm. So storage class provides a way for administrator to describe the class of a storage they offer. So here if you see the storage class resource, if you see here provisioner, so this is the annotation we are using for AWS. And if you see AWS Elastic Block Store, this is an config example, and Azure disk, and GCE physical, sorry, persistent disk. Okay, so this is a storage class. So we will define provision.io/Kubernetes. The storage class will tell that it will go and talk to the AWS and will try to create the physical volumes. And this is an um, Azure, okay, Azure storage class, and SKU name standard-LRS. So like we have a provisioned volume general purpose in the AWS, same way in the Azure we have a different types of volume types. So you can use which one you want, and which location, the region, and storage account. So in Azure we have a concept of to storage account. So that account name from where you want to create this volume. So this storage class will be created. This is also one resource, okay, inside the uh, cluster. And if you see, this is an GC. So this is a storage class, and this is the annotation we give kubernetes.io/gce hyphen persistent disk, and type which type of storage, like as I said, provisioned, magnetic in AWS. Same way, different types of storages will be available in each and every cloud. So file system type ext4. So this storage class first will create, and then this name, whatever the name we are giving here, this name we will provide inside the PV or PVC. So when we are trying to create this PVC, then whatever the storage this class name you are available, so that name will be provided. So it will intimate to the storage class, and then automatically it will create a PV. Okay. So if this is an AWS and you have already storage class has been created, okay, and you are creating this PVC, in the PVC you will have a definition of storage class. Then what it will do, it will intimate to the storage class. So if you go to this assume this is the storage class, then what will do, storage class will go and create PV in the AWS. Means what, it will create a volume, EBS volume. So generally how you will create EBS volume, you'll go here and you will go to the volume section where it is instance. Okay, here volume section, you'll go and create a volume, and that volume will be used in any of the virtual machine. But here what will happen, when the PVC is created, it will create a PV. So it will create a it will intimate to the AWS, and it will create a volume automatically, and that volume will be used to this PV. That is called dynamically creating. But the dynamically creating means you need to have already storage class should be created inside the uh, cluster. Otherwise, how come PVC? How come it knows that it should create a PV? So from where it will create? So PV means these many ways you have. So in this PVC, you need to tell in which way you want to create a, what is your source to create a volume, that you need to define in the PVC. Then only it will create a PV automatically. So you cannot use this one Azure Disk Storage class inside the AWS, because this is for creating volumes inside the Azure, not in the AWS. So this storage class you need to create inside the Azure, okay, not in the AWS. So same with this one. This is in the GCP. So GCP is also having concept called GCE persistent disk. That is similar like AWS block store inside the AWS. Same way GCP also having GCE persistent disk. If your cluster is in the GCE, whether it can be GKE or whether it can be manually installed Kubernetes cluster, it can be anything. Then if you create this storage class, just copy this and put it in some file, create it, and then when you're trying to create PVC, then automatically it will create a PV, and that PV will be used. So the advantage of creating dynamic PVC is here, when assume it's a static, I'm creating 100 GB PV manually. Assume it can be anything, it can be AWS block store, if it is AWS, or if it is an Azure disk, if it is an Azure cluster, okay, anything. Now only one PV is there, and this PV, so now I'm creating one PVC, and PVC request is 20 GB. Okay, I'm defining PVC request is 20 GB, and this PVC I'm going to use it for some pod. So now whatever the 100 GB is there, this PVC is going to use this 100 GB. Means we have only one PV, so this is going to use this PV for this PVC. Remaining 80 GB is getting wasted. Means it is expecting only 20 GB, and it doesn't have PVs with 20 GB. So that's why what it is going to do, whatever the available PV is there, it is going to take. If it is 100 GB but you are expecting more than 100 GB PVC, then it cannot able to use this PV. It will show in the pending state. It will wait for the required size PV. Okay, until it's available, till that time it will show in the pending state. So that's why the static is disadvantage is, even if it is 100 GB or expecting 50 GB, it will take it. Okay, this 100 which is going to take, and it will use 50 GB. Remaining will be wasted. Okay, you cannot use remaining 50 to some other PVC. You cannot logically divide these two different PVCs. So here that's why you're calling it as a physical volume claim. This is not logical volume. So physical volume claim is claiming this one and will use it. If it is dynamic, then whenever PVC is getting created, then PV also get created with the same size. So that's why sometimes dynamic is recommended. Okay, so this is about the dynamic binding. So this PV is binding to a PVC. A user creates, or in the case of dynamic provisioning, user creates means when a user creating an application, then he is expecting a PVC for his pod, or else the dynamic provisioning has already created a persistent volume claim with a specific amount of storage requested and with certain access modes. Control loop in the master watches for new PVCs, finding a matching PV if possible, and binds them together. Okay, if a PV was dynamically provisioned for a new PVC, the loop will always bind that PV to the PVC, which means if it is not static, dynamically PV got created for a new PVC, then always that PVC will use the same PV. Otherwise, the user will always get at least what they asked for, but the volume may be in excess of what was requested. So that is what I said. If it is static, the PV size may be more compared to PVC. So regardless how they were bound, a PVC to PV binding is a one-to-one mapping using a claim reference which is bidirectional binding between the persistent volume and the persistent volume claim. Claim will remain unbound indefinitely if a matching volume does not exist. So means as I said, PVC physical volume claim will be in the pending state. Okay, until it gets the right PV, the size. Claims will be bound as matching policies become available. For example, a cluster provision with a many 50 GB PVs would not match a PVC requesting 100 GB. The PVC can be bound when a 100 GB PV is added to the cluster. Okay. So pod uses claims as a volumes. Means here this is the PV we are creating. Okay. So this PV we are from this PV we are creating it as a volume, physical volume claim, PVC. And from this physical volume claim, we are going to create a volume. Okay. So from this PVC, we are creating a volume. And this volume details we will define inside the definition file, YAML manifest file. We call it as a manifest file, whether it's a deployment.yaml file, whether it can be daemon set.yaml file, how you want to deploy your application. As I said, maximum it will be kind will be deployment. Okay, so there you will define in the container specifications to use this PVC as a volume. We will give as a name. I will show you when I will deploy the application. So this way we will use it. Okay, so mounts that volume for a pod. For volumes that support multiple access modes, the user specifies which mode is desired. Okay, we will discuss what is this mode, access modes. Once a user has claim and that claim is bound, the bound PV belongs to the user for as long as they need it. Users schedule pods and access their claimed PVs by including a persistent volume claim. Mm, Now reclaiming policy. Okay, means whenever you are creating a PVC or PV, so how you are going to reclaim. So when a user is done with their volume, they can delete the PVC objects from the API that allows reclamation of the resource. The reclaim policy for a persistent volume tells the cluster what to do with the volume after it has been released of its claim. Currently, volumes can be either be retained, recycled, or deleted. Means when the volume is creating, so by it's having configuration. So how you want to use it back. So by default, it is in the retain. So the retain means what? Reclaim policy allows for manual reclamation of the resource. When the persistent volume claim is deleted, the persistent volume still exists and the volume is considered released, but it is not yet available for another claim because the previous claimant's data remains on the volume. An administrator can manually reclaim the volume with the following steps. Means I created this volume, so whenever this volume is it will be in the retain, means but the default option is retain. If you don't want that, we can change it at the time of creating this PV. So when this PVC is using this PV and mounted the on the pod, and there is some data has been generated, and later on that pod got deleted, means we don't want that application, we deleted that pod. But this PVC was using by this as a volume inside the pod. So when the pod got deleted, this will get deleted, but PVC will be remain same. So when you delete PVC also, okay, so till that time, this state will be in the which state? So persistent tells the cluster what to do with the current. Okay, so it will show it as into the release state. Okay, but when you delete PVC, it will show into the release state. But this PV again you cannot use it for the another PVC. It should be in the available state. Then only it will able to access. Why? Because you deleted the PVC, but whatever the data got generated from this pod, the data still remains in this PV. That's why it cannot able to attach it to the another PVC. So when you create new PVC, then it is not going to attach it to this PV. Okay. So for that, what you need to do, delete the persistent volume, the associated storage asset in external infrastructure, such as an AWS, EBS, GCA, persistent disk, Azure disk. Okay. These are the storage volumes providing by the cloud vendors. Still exists after the PV is deleted. Or manually clean up the data on the associated storage asset accordingly. Manually delete the associated storage asset, or if you want to reuse the same storage asset, create a new persistent volume with the storage asset definition. Okay, so these are the things. Only thing is delete the persistent volume, again recreate it so that it will get created once again, and whatever the data will be there inside that, it will be deleted. Okay, so here assume if this is an created from the AWS and from the AWS EBS, the volume has been created. Okay, so you need to take the backup of this EBS. Okay, you can take the snapshot and then you can delete this. So the data will be available in the real time. This is how it happens because the volumes can be taken as a snapshots and then you can delete the PV. In case if the PVC is been removed, then without deleting the PVC, you cannot delete the PV because PV is dependent on this one. So that's why you cannot delete PV without deleting PVC. After deleting PVC, you can take the snapshots of this PV and then you can delete it. You can recreate so that again you can use it for another PVCs. So this is how it happens. And another option called delete. Okay. So for volume plugins that support the delete reclaim policy, deletion removes both the persistent volume and object from Kubernetes as well as associated storage asset in the external infrastructure such as AWS. What it will do, it will, when you are deleting the PVC, if you configure this PV with the delete option reclaim policy, then this volume PV also get deleted, and in the EBS volume, what are the volume got created for this PV, that is also gets deleted. Okay, so if you go and check in the console, AWS console EBS volumes, it will get deleted from there also. From here also it will get deleted. If you mention the reclaim policy is delete, okay, and recycle, this I think this is deprecated, I think so, recycle. Yeah, the recycle reclaim policy is deprecated. Instead, the recommendation approach is to use dynamic provisioning. Okay, so if supported by the underlying volume plugin, the recycle reclaim policy performs a basic scrub on the volume and makes it available again for a new claim. So what it will do, it will not delete anything, but the same, it will be erased everything and it will use it for another volume. Okay, so that is recycle. This is a reclaiming policies, and it's a very huge topic. See, this volumes concept is very huge. Okay, I think today also I cannot finish this. Maybe it will take tomorrow also. I am taking enough time to complete this. I don't want to just show some YAML files deploy, because after taking 3 sessions also still lot of things is there inside this volumes concept. So you need to do very good practical. Okay, that's why I'm giving step by step detailed idea how we can implement. See, if I can show one example, but if you guys are working in the real time, if you're having GKE, then you need to practice creating a storage class in the GKE and how to get storage from the persistent disk of GCP persistent disk. If it is AKS, how to use Azure disk. So again, it's a different steps. So different clouds. We can take one cloud and we can use one example. Okay, but understanding point of view, I'm explaining, uh, keeping in mind about this all these three. So concept will be the same, only storage class will be the different. And as I said, these are the different types of persistent volumes. Okay. Anything theoretically still we need to discuss? Yeah, one more thing is there. Okay. When I'm creating a persistent volume, access modes. Okay. This is very, very important. The access modes are, a persistent volume can be mounted on a host in any way supported by the resource provider. So if you see read write once means the volume can be mounted as read write by a single node. Read only many means the volume can be mounted read only by many nodes. Read write many means the volume can be mounted as read write by many nodes. Okay, so which means here I think we don't have enough space. Let me take another one. Here assume we have 3 worker nodes and we have a deployment. Okay, with 3 replicas. Then what it will do? It will go and create inside these 3 worker nodes, right? And now assume we have a storage. You created a storage PV, and from this PV it created some PVC, and this is assume volume. Okay, now this has been mounted on this 3. Obviously the traffic is coming to these 3 pods with the help of internal load balancer. Okay, for this service we are getting one load balancer. And for another service, microservice, we create. So this is one of the service. If you have 15 microservices, okay, to run your application, to run your website, whatever it may be, this is one of the microservice which is having for high availability 3 replicas. And to 3 replicas means how the load will be distributed through the load balancer. Now load balancer is configured. Now whatever the traffic is coming to this load balancer, it should divide, right? So we call it as a read write transactions. Read means what? From front end, if any customer is accessing it, okay, assume it's in Flipkart. Okay, in Flipkart we have a lot of options: men's, kids, okay, women, different category. Assume for men is one microservice. This is a men microservice. Now I went and I was looking for some shoes. Okay, that is called read transactions, right? Read means what? I'm not purchasing anything. I'm just doing read. Means I'm viewing like what kind of shoes are available. So this load balancer should send traffic to all these three, right? Then that is the point of having 3 replicas. Then if it is only sending to one, then what is the point of having three? Then it should send to all the three. For example, user one is purchasing something and that request sent to this one. That is called write transaction. Write means what? Your data is getting changed. You are having 10 iPhones, one person is purchasing one iPhone and remaining are only 9, right? Means something is getting modified. That is called write transaction. Another user is also doing the same, some other transaction is doing, and that request should go here. And same way, some other user. It should be like a round robin fashion, right? Now, what it called read write many means this volume, whatever we are providing, it should able to handle read write many, read transactions many, write transactions many. Okay. So here, if you configure, how you are configuring read write once means the volume can be mounted as a read write by single node. Means it cannot be, okay, only one node, one pod wherever it is getting created, only one can take the read and write transaction. Remaining cannot take the read and write transactions. Okay. Read write many means the volume can be mounted as a read write by many nodes. So this can be mounted on many nodes and they can accept the read and write both the transactions. So when you are creating, you should be careful like how you are creating. Okay. So as shown in the table below, providers will have different capabilities. And one more thing is, if you again it depends upon your storage provider whether they are capable of giving this feature. Okay. So now let's see here. If you see Elastic Block Store, read write once, read only many is not available for it. Okay. Azure file is having all read write many, read only many, read write once. Okay, this is like a shared storage. Azure Disk is also having only read write and CephFS file system, and GC persistent disk is having two options: read only many, read write once, but read write many is not available. Okay, again this is having Qbyte. NFS is also having full option read write many. So this is the storage access modes. So what are the volumes you are creating? So based upon which storage you are using, in which cluster you are, based on that you need to decide this one. Okay. Mm, so the volume will be in one of the following phases. Available means what? A free resource that is not yet bound to a claim means the physical volume, and bound means the volume is bound to a claim. Okay, when it is bounded to as PVC, then the phase will show as an bound. When PVC got deleted, as I said, PVC got deleted, okay, but this 100 GB volume will be seen as an release state, okay, but it cannot be used. It can be used only when it is in the available state. Failed means the volume has failed, it's automatic reclamation. So these are the different phases. Okay. Now what I'm going to do, um, this is my repository. Go here. First, I will take the example of host path. Host path means, see, whatever the host path we discussed previously, that is different, and here it is different. Mm, because if you see on the top, physical volume. Okay, if you see here, the physical volume creation, we have an option called host path also. Okay, means I can create with host path also. Tomorrow I will show you, because already I'm using AWS, right? So I will show you by creating volume from this AWS and how we can create this one PV. Okay, and with that PV, how we can create PVC. I will show you how to create pod. So now what I'll show you, I'll create a host path. So again, what is host path? Single node testing only, local storage is not supported in any way and will not work in a multi-node cluster. Means what it will do? This physical volume concept only, I'm creating it as an host path. Means here it will create, let's say in this machine, wherever I'm trying to deploy, in that machine it will create one PV by using the local storage. So that's why host path is not for multi-node cluster, because when the pod is getting deployed here, then it will create a PV by using the local storage of this machine, and it will create a PV, and that PV will be created as an PVC, and that PVC will be used inside the pod. Okay, but that is also not recommended in the real time. We need to use either EBS if it is AWS, and Azure disk, or maybe GC percentage. That I will show you tomorrow. Okay, so how to do that, and also we'll discuss dynamic provisioning also we'll discuss. So this is what we are going to discuss now, is a static provisioning. Means manually I will create PV, and then manually I will create PVC, and that PVC I will give it to the pod, so that pod gets created and we'll use it. But basically the recommended is this PV should be external storage. So that we'll discuss tomorrow. Today I will show you by using internal this cluster storage itself. That's a concept of host path. Host path. Okay, means it will create here. So that's why it is not possible to have multiple replicas, single replica only. And if the pod gets deleted, if the pod gets created here, then that local mount will not be get created here. So that is not recommended. But just to see how to create PV and how to create PVC, okay, we'll discuss. Okay, quickly I will show you, and tomorrow we'll discuss in detail way. So here inside this Kubernetes, if you see PV-host path, okay, so let me copy this. Hmm, okay, or else I'll create a directory called storage. I'll put all these files inside this directory. So now first I would like to create a physical volume vi pv.yaml, or maybe pv hyphen hostpath.yaml. So here I'm copying it. Sorry. Okay, so for host path, we are not using any what we say, AWS storage, or maybe Azure storage, or maybe any external CFFS. We have different storage types. We are not using it. For host path, that's why I'm using as a manual here. Okay, storage class name is manual. In case if you are using AWS block store, then before creating persistent volume, you should create a storage class first. The uh, manifest file which I've shown you. So first you need to create this one. So again, it depends upon you, IOPS per GB, how much you are giving. Okay, that is depend upon you. It's 1,000, 10,000, how much you want to give file system. Okay, so this you need to provide. This should be created first. Storage class should be created, and what are the name you are giving here? This name should be provided here, storage class name. Then it will contact the storage class name, and storage class will go and talk to the AWS, and it will get created the volume. Okay, but as of now I'm using local host path, so that's why it is as a manual. Okay, and capacity 1 GB PV I'm getting created. If you see, this kind is PV, and version 1 means it's very old object. We discussed about this API versions. Apps v1 means it's latest object. v1 means pretty old object in the Kubernetes. And access mode, you can see read write once. Always we can use only read write once. This is an local host path. And host path is getting created /cube. Okay, because it is using the storage of this particular worker node. Okay, wherever it get deployed. So in this local storage, it is getting created /cube, and that /cube is creating as a physical volume from this worker node. So if this is a worker node, so here it is getting created /cube. So it's acting like a physical volume, and this physical volume you can use it for the physical volume claim. So now let me use this kubectl create -f. Already exists. Okay, kubectl get pv. Okay, this is already available. Kubectl. I'm not sure. Okay, it's already, if you see here, this is in the release state, but this is in bound state. So first I need to delete the PVCs, because here if you see, it's bounded to this PVCs. This will be deleted, but this will not be deleted because status, if you see, this is bound to some volume. Let me open. It is taking time. Okay, anyhow, we can execute this command now. cd storage kubectl create -f got created. Kubectl get pv. If you see, this is in available state. Just now I created this one. and the name I given inside the YAML file is pv-host path. The capacity is 1 GB and access mode read write once. Reclaim policy retain. By default, I did not mention here inside this, I did not mention, but by default, it will take these policies. Like for example, if you want to see kubectl get pv hyphen o YAML. I want to convert into the YAML file. So whatever the default options will be there, that will be visible. Where it is? See, persistent volume claim policy retain. When you want to change it, then you need to give this value, same exactly like this, and yeah, then you can change it here, delete or recycle, what option you want to give, then you can give here. By default, it is taking it as an retain. Okay. So these are the subcategories of this spec field of the volume. Whatever, let's say spec under for volume, there is 100 specifications, but manually we are giving only few. Remaining all will take by default. Okay, that we need to go in the API of this persistent volume. There we can able to see. So now this is retain. Status available means any PV can take this. If you see here claim not claimed by any PVC, and storage class is manual. Now what I'm going to do, I'm going to create a PV. Okay, so in the same sorry, PVC I will create the same repository. We have a PVC hyphen host path. This is two files. We go to the PVC, and here I'm selecting. Okay, clear this. Now vi PVC hyphen health. No, sorry, host path dot YAML. Now if you see, this is persistent volume claim kind is, and what is the name we want to give, it's up to you. What are the name? This is PVC, and for PV I give PV hyphen host path. For PVC I'm giving PVC hyphen host path. And again, if you see storage class name, here we are giving manual. What are the storage class we are using? It's a default manual. And this PVC is also here. I'm not telling to use specific PV. Okay, I'm just claiming if PVs are available, then it gets created. If PVs are not available, it will give in the pending position. It will wait till PV should be available. Okay, so resources request is I'm doing 100 MB only. Okay, now when I create this, let me do before this. Yeah, let me save this. And before that, kubectl get PVC. Let me check. There is a save with same name one is available. So kubectl delete PVC. Kubectl get PV. Okay, this is the one which I created. It's showing now. And for PV and for PVC, nothing is showing. Now I can create. These are two old PVs. Okay, we can ignore that. Kubectl create hyphen f PVC hyphen host path. Now kubectl get PV. If you see here, bound previously it was showing available. This one host path 1 GB. Now it is showing bound to this PV. Okay, it's showing status also bound. So I created 100 kubectl get PVC. If you see, I raised request for only 100 GB, 100 MB, but it is using 1 GB volume because apart from that there is no other volume found for that PVC. That's why it took 1 GB volume. Okay, so quickly what I'll do, I'll create a, this is the busybox.yaml. You can use this. I'll use this one, vi busybox.yaml. Okay, so now if you can see here in the container specification, first of all, in the volume specification, you can see this is as I said, PVC will be used by the volume. So in the volume section, I'm giving some name, some volume name, and what I'm giving to use this to have this volume, I should use persistent volume claim. So this is a PVC name. What are the PVC got created? This is the name of that PVC. So this is acting like a volume inside the pod. And in the container specification, this volume is getting mounted here. If you see volume mounts, the name of this volume is getting mounted inside this container. And mount path, what are the application file system path is there, that path you are going to give. So this volume will be mounted inside this one. And how this volume is getting created? By using this persistent volume claim, it's getting created. And where it got created? From the PVC. So now if I save this and kubectl create -f busybox.yaml file, kubectl get parts, busybox is running, right? So now if you go kubectl execute -it, logged into that container, and if you see here, my data has been available.